So a model is a algebraic equation or function that you use to model a real life situation. So that's what these are all about. So on example 1, a projectile is fired straight upward from the ground with an initial speed of 160 feet per second. And the function s of t models the projectile's height above the ground in feet t seconds after it is fired. We want to know the period of time that the height will exceed 384 feet. Now, back towards the beginning, it was probably August when we worked problems like this. So we're going to solve quadratic inequalities. So we would take this s of t, and if we want that to exceed 384 feet, what should we do? Like, what should we write? Greater than, good. Greater than 384 feet. Right? So I'm not sure if y'all remember, but what we did with these inequalities is we solved the corresponding equation. So we would change it to an equation. Whoops. And then solve it. And then there's more to it. So we have to do some things after that, but that's the initial part. And so since it's quadratic, we're going to get everything on one side. And then we're going to solve it for t. In this one, 16 divides evenly into everything. So I'm just going to divide through by negative 16. And then that gives us a pretty easy equation to solve by factoring. So we get two values where it's actually the function would be equal to 0 there. So what we'll do is put them on a number line. Now I'm stopping my number line at 0 because negative seconds doesn't make sense. Do y'all remember doing this?
Yes.
Good. All right. So then we're going to plug in a value in each region and see if we get a true statement or if we get a false statement. And I'm going to plug them into the original. So plugging in 0 is super easy. So everything that has a t becomes 0, and we get that 0 is greater than 384, which obviously is not true. And when we plug in 5, it's a little bit more difficult. And I didn't really give myself a lot of space. So it's going to be negative 16 times 25 plus 160 times 5. We want to know if that's greater than 384. And I did this before, and I got that 400 is greater than 384, which is true. Whoops. Right, and then when we put in 7, we get 336 is greater than 384, which is false. So this region between 4 and 6 is our solution region. So that's the time period between 4 and 6 seconds. So I'm going to write that somewhere where I have room. Now, example 2 is similar. We have to write the model though, so this one's a little bit more difficult. So for that one, with a rectangular room, fits at least 7 tables that have 1 square meter of surface area. And we know the perimeter of the room is 6 meters. We want to find, between what two values must the length of the room fall? Okay, so using the table situation, if there's 7 tables at least that fit in this room, then the length of the room times the width of the room, so the area of the room has to be greater than 7, or the tables won't fit. All right, and then what's the perimeter formula? And that we know the perimeter of this room is 16, so 2L plus 2W is 16. Now, the answer to the question is all about the length. And so what I would do is take this one and solve it for W. So whatever you're looking for, solve for the other variable. And so that's going to be eight minus L. So what I would do is take that and plug it in. Okay. And then we have another inequality to solve. It is going to be quadratic. I'm going to go ahead and distribute the L. And then I'm going to solve a corresponding equation. I'm going to rearrange it a little bit though. Right now I don't like this negative in the front, so I'll just divide through by a negative or just change all the signs. And then it's pretty much the same thing we just did. We're going to factor it. It's super easy to factor. All right, and then we'll put that on the number line. And what I'm doing is I'm testing a point in each region. All right, so I'm going to put in 0, and I'll put it in for this one right here. Put in 0, I'll get that 0 is greater than 7, which is false. I'm going to put in 2. I get that 12 is greater than 7, which is true. And then when I put in 8, I get that 0 again is greater than 7, which is false. All right, so it looks like the length of the room must be between 1 and 7 meters. All right, so example 3 should feel familiar to you because we just recently did this in unit 3. So we did a ton of we had elk and we had deer and we had bison and I don't know, we had tons of different animals. So this time we have a herd of elk is released onto state game lands. The expected population, P, of the herd can be modeled by that equation, where T is time in years since the initial number of elk were released. What is the horizontal asymptote of the function, and describe what it means in practical terms? Now, normally on our horizontal asymptote, we'll say y equals, and if you do that, it's fine. But I'm going to say p equals because this problem doesn't have a y. And the horizontal asymptote, you compare the degrees of the numerator and the denominator. And so someone in my last class was like, what's a degree? So I need y'all to know that it is the largest exponent. So what do you guys notice about the degrees? They're the same. Do you remember what to do when they're the same? Is it what? Yes. So you divide the leading coefficient over the leading coefficient. Now, someone in my last class also said, why is it not 10 divided by 1? Do you guys know why? Those aren't coefficients. Those are constants. The coefficients have to be in front of the number, the letter, or the variables. So it's going to be 9.6 divided by 0.2, which a calculator that's not very smart can figure that out. That's 48. And then what is 48? Is it time? Is it elk? It is not time. After a really long time. So after many years, the population levels off at 48 elk. All right, the next three are older than that one. It's been a while since we've talked about variation and average rate of change. Like I think that was probably back in like the second unit that we did, but it's okay. You can remember. So, for example, 4 and 5, these are variation problems. And if you guys remember, what we did is like when it says something varies, we would be like D equals K, and then we would figure out if you would multiply or if you would divide. Do y'all remember that a little bit? Ish. Okay, it's all right. So the distance of an object falls in t seconds. Sorry, the distance an object falls in t seconds varies directly. So when you see that, it would be d equals k. So distance varies directly with the square of t. So for direct variation, do you multiply by the square of t or do you divide? Direct, you multiply. Good. Now, I don't think this is a very good problem because the rate that things fall on Earth is constant. It's gravity. So let's say this is not on Earth. So we can figure out K. K is the constant of variation by plugging in values. So I know that an object falls 7 feet, which is a D, in 1 second, which is a T. So we would say that 7 equals K times 1 squared, or K is 7. K, like gravity is never 7 on Earth, so I don't know. It's okay. So we would rewrite this problem with K, that's 7. And then the question is asking, how long will it take an object to fall 112 feet? So what do we do with that 112? Plug it in for T. So we can solve that for T by dividing by 7 and then taking the square root.
Do you divide or take the square root first?
You divide first. Now, normally when we take the square root, we take the positive and negative square root. Does negative time make sense? No. So we're just going to do the positive square root. So the answer to this question is 4 seconds. Right. Example 5 is on the demand of a product based on how much is charged on that product. So a company found that the demand for its product varies inversely. So I'm going to do D for demand. Because it says varies, I'm going to do K. We have to find that constant of proportionality. And for inverse, what do I do with the P? Divide. And that makes sense. Like the more that a company charges for a product, the less they're going to sell. So we know that when the price is $3.50, which is a P, the demand is 800 units. So I'll plug those in and find K. So I would just need to multiply 800 by $3.50, and you're going to get 2,800. So I have my formula I need to find the demand based on the price charged. Okay, so basically we want to figure out for the final answer how many units that they'll sell if they charge $4.75. So I'll put that in for P. And I already typed this in the calculator. I know you guys can type things in the calculator on your own, but you get approximately 589 units. So they're going to sell less. They may make more money, depending on, we can figure it out, but I don't really want to. All right. Example 6 is another thing we haven't talked about in a while, which is the average rate of change. Now, average rate of change is something you spent a ton of time talking about in Algebra 1. Do you guys remember what the average rate of change is another way of saying? The slope. Now, if you all take calculus, you will know what average rate of change is from day one because we talk about it a lot. Do you guys remember the slope formula?
X sub 2.
X2 minus X1.
Changing Y over changing.
Changing y over changing x. So y is on the top, x on the bottom. Okay, so I guess I should read the problem. The distance s in feet a car is moving from a stoplight is given by that function, where t is time in seconds. We're going to find the average rate of change from t equals 1 to t equals 4. Now, the slope formula we use is x and y, but we can do it for t and s too. So these are, like if you're thinking of x and y, those are both x's. So we need to find the y's that go with them just by plugging them into the function. So 1 to every power is just 1. So this would be the ordered pair 120. So when we plug in 4, it's a little bit more difficult. What does it mean to raise something to the 3 halves? What does it mean to raise something to the 1 half? Square root. So we do the square root of 2, the square root of 4, which is 2. And then what do we do with it because of that 3? You don't multiply by 2. What does that 3 tell you to do to it? Cube it. So that would be 2 cubed, which is 8. Okay, so we did the square root of 2 and then cubed it. And that is going to give us 160. So that's the ordered pair for 160. And then from here, we're just going to do the slope formula. And this one doesn't reduce. It's okay. We get 140 over 3. So what do you guys think the unit should be for the average rate of change for a distance?
T.
So that 160 and 20, what were they? Were they feet or were they feet or were they seconds? They were feet. So it's going to be feet on the top, seconds on the bottom. So feet per second is the average rate of change for a distance. Just a velocity. Okay, number 7, hopefully, is super familiar to you. And hopefully you didn't just take the test on this and then completely forget it as soon as you took the test. I don't know. But this one uses a half-life formula. So I am using A and P on half-life. I don't know. It doesn't matter what those are as long as you know what they stand for. And it's 1/2 is raised to the T over K. Oh, good. All right, so radioactive element carbon-14 has a half-life of 5,000 715 years. That's going to be a K in a second. A piece of charcoal from an ancient campsite has 20% of the original amount of carbon remaining. I don't know how they know that, but that's okay. We're going to determine the age. So I don't know the initial and the final amount, but I do know that when I divide those two, that I'm going to get 20% or 0.2. So I can just go ahead and set it up that way. And since that's a decimal, I'm going to go ahead and do 1/2 as a decimal. It doesn't matter. But for K, I'm going to put in my 5,715. All right, how do I get that exponent down? Take the log. Let's take the natural log of both sides. All right, then I'll bring the exponent down. Right. And then you can kind of do this in whatever order you want to. I particularly don't really like that fraction. So when I see that 5,715 on the bottom, I'm just going to multiply by it. And then I would divide by that logarithm. So T is going to be equal to that many years. Now, I have no idea what that equals. That's okay. It's probably a lot if it's ancient. All right, what questions do you guys have about models? When you start doing your review, you're going to be grateful for this lesson because it's gonna help you out on several of them.